Okay, let's unpack this. We're doing a deep dive today into, well, a story that almost sounds too dramatic to be true. It's a near disaster at a nuclear power plant,
Right.
and not somewhere distant like, Fukushima, but right here in the U.S., Browns Ferry, Alabama, back in March 75.
Uh, and it's striking you bring up the time of year, March, April.
Yeah.
Seems to be this period with an unfortunate connection to major nuclear incidents.
Yeah, like Chernobyl in April, 3 Mile Island in March.
And here we are with Browns Ferry, March 1975.
Exactly. And this plant, it wasn't sitting idle. We're talking 2 reactors running at full power, delivering what, 2,200 megawatts?
A huge amount of power. And this incident, it started small, but it escalated. Set off a chain of events that brought both Unit 1 and Unit 2 really perilously close. I mean, within about an hour, maybe less, a core meltdown.
Wow.
So our dive today is really based on the sources you've shared. We're exploring the specifics of this Browns Ferry fire,
Right.
looking at what happened, the challenges they faced, and maybe most interestingly, the parallels it has with events much later, like Fukushima, decades later, really.
So let's set the scene. This whole thing kicks off in a place called the cable spreading room. Can you describe that?
Yeah, think of it as this absolutely critical location that's just below the main control room,
Okay.
sandwiched right between the turbine building and the reactor building.
So kind of the nerve center.
Exactly, yeah. The heart and brain, you could say.
Yeah.
Controlling the reactors. It's just packed floor to ceiling with all these essential electrical cables.
Mhm.
And crucially, there has to be absolutely zero airflow between the turbine building that's the non-safety side and the reactor building, the safety side.
Makes sense. Why is that?
Well, it's to prevent any potential radiation, if there was an accident on the reactor side, from leaking out. It needs to be airtight.
Right. So sealing any holes where cables pass through, that's like a vital job.
Vital, routine task. Which brings us to the spark. The sources describe this seemingly simple task just going unbelievably wrong.
How simple?
Well, 2 construction workers were doing exactly that, finding and sealing air leaks between the buildings. They were using polyurethane foam.
Which is?
Highly flammable, as you might guess.
Right.
And their method for checking for drafts in these holes.
Let me guess. Something low tech.
Extremely. A lit candle. They were watching the flame, to see if it flickered from a draft.
A candle in a nuclear plant's cable room. It sounds almost archaic, doesn't it?
It really does. And, well, the inevitable happened. One worker held the candle just a bit too close to the foam sealer.
Oh, no.
The draft pulled the flame right towards it, and poof, the foam ignited.
Just like that.
Just like that. And our mission here in this deep dive is to follow that spark. Understand the whole chain of events that unfolded from that moment. The incredible challenges the operators, the firefighters faced, and what this specific incident way back in '75 really tells us about safety procedures, of emergency response, and, well, the human factor when the stakes are impossibly high.
Because it wasn't like they immediately hit the big red button, right, those 2 workers?
No, not at all. When that phone caught fire, they didn't sound an alarm right away. The sources say they tried putting it out themselves first.
How?
Well, first they grabbed a flashlight to try and swat at it. That didn't work. Then they tried stuffing rags into the hole.
Rags? Seriously?
Seriously. For about 15 minutes, they were just wrestling with this fire completely on their own, which, right there, is a huge breakdown in protocol.
Should have hit the alarm immediately.
Immediately. And their attempts, not only did they fail, but the sources describe how the CO2 extinguisher they eventually found and used actually seemed to push the flames deeper into the wall opening.
Making it worse.
Yeah, and then a dry chemical extinguisher they tried acted almost like a blowtorch. It just intensified the fire.
Oh, wow. So it started roaring.
Literally roaring, according to the reports. After all that failed, they finally, panicked and ran to find a guard.
Okay, so then the alarm gets sounded.
Not directly, no.
Yeah.
Even then, there was a delay. The guard called the shift engineer's office, who then called the control room. And only then was the fire alarm finally activated. That whole chain, relying on someone being at their desk. It added critical, really dangerous minutes to the response time.
Unbelievable. And in the control room, were they shutting things down?
Astonishingly, no. Not right away. Even after the alarm sounded, the operators kept the reactors running.
Why?
It's unclear initially, but it wasn't until about 45 minutes after the fire first started that the Unit 1 operator noticed something really weird.
What was that?
All his emergency pumps had automatically kicked on, which is incredibly bizarre because, as far as he could tell, The reactor seemed to be running normally. The water level looked steady.
Huh. So the pumps were reacting to something he couldn't see yet.
Exactly. And then, well, then the real chaos erupted right there in the control room.
Okay.
Lights on the control panels started acting erratically. Glowing dimly, flickering, just going out completely. Alarms blaring everywhere.
Oh, man.
Smoke started pouring out from behind the control boards. Electrical sockets were literally popping. Light bulbs shattering overhead.
Sounds terrifying.
The operator first thought it was some strange malfunction of the emergency system itself and actually tried to turn it off. But it just came right back on.
Because the emergency was real.
Precisely. It took about 10 more minutes of this escalating pandemonium, with the smoke getting thicker, the noise,
Yeah.
for it to finally dawn on them. Maybe the reactor should be shut down.
You think?
Yeah. But before the operator could even properly initiate the shutdown sequence, the power in Unit 1 just started dropping, drastically on its own. And the main cooling pumps quit.
So the fire was already crippling the system.
Absolutely. At that point, about 55 minutes after that first spark from the candle, the operator finally hit the main shutdown button, the scram button.
But the damage was done.
Extensive damage. All control power, most of the electrical power for both reactors gone, all the safety equipment, the core protection systems for Unit 1, completely lost.
Okay.
Except for one single small pump.
Was that enough?
Not even close.
Okay.
Totally insufficient for properly cooling the core. Unit 1 was in serious trouble.
And Unit 2?
Unit 2 was facing its own sort of parallel nightmare, similar losses, key safety systems knocked out, critical instruments going dark, communications failing.
So they were flying blind in both units?
Effectively, yeah. Becoming blind. Unit 2 also managed to avoid a meltdown, but the sources say it was by an equally thin margin. It had, I think, one different but similarly limited low-pressure backup system that happened to still work.
Wow. So this is where the human element really comes in.
This is absolutely where it shifts. With almost all the instruments dark, safety systems disabled by the fire, the operators, they had to get creative. Under pressure, you and I probably can't even imagine.
What could they even do in Unit 1 with just that tiny pump?
Right. The operator knew that pump wasn't enough. He had to figure out some way to get more water into that core, even though he couldn't really see what was happening inside the reactor vessel anymore.
So what was the plan?
He made a really critical decision to try and depressurize the reactor.
Why depressurize?
The hope was if they could lower the internal pressure enough, they might be able to use lower pressure pumps to force water in. If they could find any that were still functional after the fire damage.
A big if.
A huge if. And by the time they actually located a working low-pressure pump that could push enough water, the water level inside Unit 1 had dropped to just a terrifyingly low point.
How low?
48 inches. Just 48 inches above the top of the nuclear fuel core.
Wow. Okay. That's cutting it incredibly fine. Almost uncovered.
Frighteningly close to exposure, yeah. And the Unit 2 operators, they had to figure out similar things, how to depressurize their reactor, find working low-pressure systems. These actions basically inventing alternative cooling methods on the fly with almost zero information. It was nothing short of heroic.
Just pure improvisation under the worst conditions.
Absolutely. The sources we looked at, they explicitly draw parallels between what these Browns Ferry operators did and the kind of heroism we saw decades later at Fukushima.
How so?
Well, at Fukushima, too, operators had to find unconventional ways to get cooling water to damaged cores when all the normal systems had failed. It just underscores how, sometimes, human ingenuity and sheer courage become the last desperate line of defense.
There's that anecdote, too, about Operator M, Gary McChristian.
Yes, that's a powerful one. He was in the control room that day, right in the thick of it. And someone asked him later if he was scared, operating with all the smoke, the alarms, the lights popping.
And was he?
He said yes. Of course, there was a lot of fear. But he got really concerned, he said, when someone told him the ceiling of the cable spreading room below them was starting to cave in.
Because?
Because that ceiling was the control room floor.
Oh.
Yeah. The idea that the very floor beneath their feet might collapse. That added this whole other visceral layer of terror to an already impossible situation. It really hits home, the pressure they were under.
Yeah, absolutely. And while they're fighting to save the reactors, what about the fire itself? Were firefighters getting anywhere?
They were struggling just as much, honestly. It wasn't easy at all. The power loss meant huge parts of the plant were plunged into darkness. And the smoke, incredibly dense.
So breathing apparatus was essential.
Desperately needed. And the sources reveal the plant was just woefully under-equipped and unprepared on that front.
In what way?
Air packs were in short supply. Some of the ones they had didn't work properly. Some were missing masks. Others weren't fully charged.
You're kidding.
Not at all. And even when they did have a working one, the packs only gave them about maybe 18 minutes of air.
That's barely anything.
Barely enough time to get to the fire, through the smoke and darkness, try to do something, and then get back out to safety.
And getting into the cable room itself.
A nightmare. The sources describe it as incredibly crowded, with all those cables, floor to ceiling. And wearing those cumbersome air packs made it almost impossible to move around.
How did they manage?
They had to crawl on their bellies, apparently, pushing their air packs ahead of them. And in that process, one of the fire extinguisher nozzles actually broke off, just added to the frustration.
And wasn't there an issue with the built-in fire suppression system, too?
Oh, yeah. Compounding the problem significantly.
Yeah.
The automatic CO2 system for the spreading room. It had been purposely disabled.
Disabled? Why?
Apparently to prevent it from accidentally spraying construction workers who might be in there.
Okay. But surely there was a manual override.
There was.
Yeah.
But, adding insult to injury here, even the manual activation handles were blocked by metal construction plates that had been put over them.
Yeah.
Yes. They needed a screwdriver to remove the plates. A simple tool, but in the dark, in the smoke, in the chaos. They couldn't find one quickly.
So the built-in system was useless when they needed it most.
Initially, yes. They eventually did manage to get the CO2 system turned on later.
Okay, good. Did it help?
Well, activating it had the perverse effect of driving even more smoke directly up through the floor penetrations into the control room above.
Oh, come on.
Yeah, forcing the operators up there to choke and cough, threatening to make the control room completely uninhabitable. They actually had to turn the CO2 system off again, and the fire just kept burning.
This is just one failure cascading into another.
Exactly. So eventually, the local Athens Fire Department arrived, about an hour and a half after the fire started.
Okay, professional help. That should make a difference.
You'd think so.
Yeah.
But they immediately ran into another major problem. A conflict, really.
With who? Plant management.
Yep. The Athens fire chief looked at the situation and believed it was a Class A fire, meaning, ordinary combustibles burning the foam, the cable insulation.
So it needed water.
That's what the chief thought. Needed water to extinguish it properly. But the plant management, they were strictly following TVA policy for electrical fires.
Which is
no water. They insisted it was a Class C, an electrical fire, and water absolutely couldn't be used because of the risk of shock or spreading the fire through conductive water.
even though the main fuel seemed to be the foam.
Right. This dispute went on for hours while the fire just raged. Plant employees were using extinguishers designed for electrical fires, Class B and C, on what the Athens chief correctly saw as mostly a Class A fire fueled by that polyurethane foam.
So did they ever use water?
Finally, yes. Around 6 p.m., hours after the fire started, the plant superintendent finally relented and gave the Athens Fire Department permission to use water. Predictably, it worked. Quickly. The fire was basically out in about 20 minutes.
Hours wasted arguing. Wow. But the reactors were still in danger.
Oh, absolutely. The situation, particularly for Unit 1, was still critical. The pressure inside was increasing, and they were constantly at risk of losing the ability to inject any cooling water, which could still lead to meltdown within hours.
So another moment for improvisation.
Exactly. This led to another crucial bit of operator ingenuity under duress. One of the shift engineers remembers something.
What was that?
A system that had been installed way back during construction. It could potentially be used to depressurize the reactor using nitrogen gas.
Because the normal systems for that, using compressed air, had failed.
Right, failed due to the fire damage. So operators had to physically go back into the still smoky reactor building, find the right valves, and manually line them up to activate this backup nitrogen system.
Incredibly risky.
Very. But they did it. And finally, around 9:40 p.m. that night, they began using the nitrogen to slowly bleed off the pressure in Unit 1.
And that allowed them to cool it properly.
Yes, it allowed those low-pressure cooling systems they'd managed to get working to be much more effective. Normal cold shutdown was finally achieved around 4 a.m. the next morning.
What a marathon.
An absolute marathon. The immediate crisis was over. Thankfully, no loss of life, though dozens were treated for smoke inhalation.
But the story doesn't quite end there, does it? There were other issues even after the fire was out.
No, it doesn't. The sources point out other emergency systems that should have worked, but failed in the aftermath.
Like what?
Like the aircraft warning lights on the main 600-foot exhaust stack. They went around after dark.
That's a serious hazard for planes.
A huge collision risk. And trying to report this apparently led to just a series of confusing phone calls. At one point, Plant staff were told by an emergency center to call the FAA themselves. Just chaos.
Do you see how these things just domino?
Yeah, and even the post-incident analysis trying to figure out exactly what happened when was hampered.
How so?
The computer printer that was recording all the event data, it ran out of paper.
Oh, you're kidding me.
Ran out of tape, actually,
Eh.
and wasn't replaced for nearly 24 hours, leaving this huge gap in the timeline, right when things were most critical.
Unbelievable.
Tape recorders meant to log important phone calls were only partially working. And maybe most disturbingly from some of the source material, there are records of some senior managers almost making light of the subsequent NRC investigation, even ridiculing the investigator himself.
That doesn't exactly inspire confidence.
Not really. It really paints a picture of systemic issues that went much deeper than just one fire caused by a candle.
So what were those bigger contributing factors the sources highlight?
Well, several things. Obviously, the initial choice to use highly flammable foam near ignition sources, that incredibly unsafe candle test method.
Right.
Then there were issues with employees not being properly trained on how to report alarms or follow emergency procedures. You saw that with the initial delay. And also the sheer chaos caused by dozens of, frankly, untrained employees just flooding into the control room during the emergency, adding to the noise, the confusion, the smoke.
Just making a bad situation worse.
Absolutely.
Yeah.
And what about the root cause, that candle test? Wasn't there some warning sign about that specifically?
Yeah, what about that?
This is where it gets truly frustrating, reading the accounts. Reports show that just 2 days, before this massive fire, there had been a similar, much smaller fire, also ignited by a candle, during this exact same leak testing procedure.
Seriously?
Yes. And after that smaller fire, the night shift engineers had actually met and explicitly concluded that the candle testing procedure had to stop.
So they knew it was dangerous.
They knew. But crucially, no follow-up action was taken. No official order went out. Nothing changed. Which strongly suggests this big fire wasn't really a matter of if it would happen, but when.
It feels almost inevitable then.
It sort of does, doesn't it?
Yeah.
And the problems extended beyond the plant boundaries, too. Emergency preparedness outside the plant.
Yeah.
Just as flawed.
How so?
Well, remember, those radiation monitors needed to check for environmental releases.
Yeah, the fire knocked them out.
Knocked them out early on. So, had there been a significant release of radiation, which was a real possibility, if the cores had melted, the operators wouldn't have known how severe it was, or how to advise the public on evacuation.
They couldn't measure it.
Couldn't measure it properly. Air sampling was delayed. And critically, they couldn't even get samples taken downwind towards the nearby town of Decatur, which is where any potential radioactive plume would have gone.
And notifying people, local authorities.
The details there are quite shocking, reading the sources. The Maine Civil Defense Coordinator for Limestone County, he wasn't officially notified until 2 days after the fire was completely out.
2 days.
2 days. The county sheriff wasn't notified either. And even if he had been, it turned out he didn't even have a copy of the plant's emergency evacuation plan.
This is staggering.
It gets worse. The sheriff of a neighboring county was actually told about it, but was apparently advised to keep quiet. State agencies didn't have up-to-date plans. It was just a complete breakdown in communication and preparedness outside the fence.
Wow. Okay, so you have this reality of near meltdown, chaos, system failures, communication breakdowns. How did that compare to the official story afterwards?
Well, that's where the discrepancy becomes really stark. Months later, the official NRC press release came out.
And?
It significantly downplayed the severity. It used phrases like, equipment function was merely impaired, said the reactors were safely shut down and cooled.
Which sounds very different from what actually happened.
Very different. Inspector reports claimed that redundant cooling systems were available, that critical instruments did work.
But they didn't, according to the operator.
Exactly. The official reports even falsely stated that the main emergency core cooling systems, the ECCS, were activated automatically and then deliberately shut off by the operators to prevent overfilling the reactor.
That's just not true.
Completely inaccurate, according to the operators who were actually there, fighting to keep any water going in, watching that level drop to 48 inches. Most of the ECCS was knocked out by the fire. It wasn't deliberately turned off. It paints a totally misleading picture of how close they really came.
It's interesting, the author of some of the source material we read actually worked at Browns Ferry later.
Yeah, years later. And he learned about the fire directly from some of the operators who fought it. including Gary McChristian.
What was his takeaway from talking to them?
He really emphasizes how these operators, despite everything failing around them, the procedures, the equipment, the communication, they just did the absolute best they could with what little they had left. They never gave up.
That connection to Fukushima again.
He makes that connection explicit. Their resourcefulness, their courage in devising those alternative cooling methods under impossible pressure. He sees it as the same kind of heroism shown decades later in Japan. It really reinforces this idea that while you absolutely need robust systems, sometimes human action, human resilience becomes that crucial final difference maker.
And the sources do say that the U.S. nuclear industry became, quote, exponentially safer today because of the lessons learned from Browns Ferry and later the 3 Mile Island and Fukushima.
And that's a critical outcome, no doubt. These terrifying events, they absolutely drove significant changes, new regulations, better emergency procedures, mandated equipment upgrades, separation criteria for redundant safety systems.
So things did improve.
Dramatically, yes. However, there's also the perspective shared from a nuclear safety consultant in the sources, which is basically expressing a desire for a world where that kind of extraordinary human heroism isn't necessary, where the systems themselves are so robust, so redundant, so well designed that you never get to that point where individual operators are the only thing standing between normal operations and a potential catastrophe.
A laudable goal. So let's try and recap this whole thing. The Browns Ferry story. It's just a stunning, almost unbelievable example, really. How a tiny spark, literally a candle near some flammable foam, can escalate into a near-nuclear catastrophe. And it wasn't just one single failure.
No, it was this confluence, this perfect storm. Simple mistakes, like the testing method, using flammable stuff where they shouldn't have.
Right.
Combined with procedural breakdowns, communication failures, alarm delays, then equipment failures, like that disabled fire suppression system, and layered on top, a disturbing lack of preparedness outside the plant itself.
And all of that disaster potential was only averted because of the ingenuity, the quick thinking, the sheer courage of those operators.
Under absolutely unimaginable pressure.
Right.
Literally improvising ways to cool the reactors when their instruments were dark and their safety systems were failing left and right.
It really hammers home the importance of seemingly minor details, doesn't it? That candle, that foam, those little metal plates blocking the CO2 valves.
Absolutely. And it highlights the absolute necessity of having robust procedures, but maybe more importantly, actually following them.
And training people properly.
Proper training, yes. Having the right equipment, functioning and accessible, like decent firefighting gear, reliable monitors, and maintaining clear, unbroken communication channels, especially when every second counts.
What's really striking is how all these seemingly separate failures just combined, they cascaded into this critical situation, pushing experienced people right to the absolute edge.
And the human element is just undeniable. The heroism of those operators, it absolutely saved the day, full stop. But as the source material also makes us think, while we celebrate that courage, maybe we should also question systems that are designed or allowed to degrade in such a way that extraordinary heroism becomes the only thing preventing disaster.
Yeah, that's a really important point. Which raises a question, I think, for you listening right now. What can we all learn from an event like Browns Ferry that applies, far beyond just nuclear plants? How do these lessons about vigilance, about following procedures, about clear communication, about how small oversights can cascade into massive crises, how do they translate to safety and emergency preparedness in any complex system, maybe one you encounter or work with in your own life?
And maybe more fundamentally, how do we ensure that these hard-won lessons from past incidents actually lead to real systemic change? Not just, lip service or inaccurate official reports that gloss over the near misses.
Yeah.
If we try to connect this to the bigger picture, this story, Browns Ferry, it isn't just about a fire in some Alabama tower plant back in 1975.
No.
It's really a powerful kind of timeless reminder, isn't it?
Yeah.
That sometimes the biggest risks, the catastrophic failures, can stem from the smallest oversight, the most mundane task gone wrong.
Highlighting that critical need for just unwavering vigilance, crystal clear communication, and a real commitment to continuously learning from every incident, no matter how small it seems at the time.
Even when the stakes aren't quite as high as, preventing a nuclear meltdown?
Yeah.
That constant learning, that's key.